Here are 5 symbols we're going to see in this video. Here's what they're called. These two are called strict inequalities because they don't involve an equal sign. Which symbols could we put in here that would make this true? -5 is less than 1 because it's negative. It's also less than or equal to 1. What symbol could we put here? 7 is greater than -12 since, well, -12 is negative. It's also greater than or equal to. Here we could put either a less than or a less than or equal to, both would be true. Here we could certainly put an equals because 2 equals 2, but it's also true that 2 is less than or equal to 2, and that 2 is greater than or equal to 2. Here we could either put a less than or a less than or equal to because the 2 is negative. Here's an inequality we'd like to solve. That means we want to find all the numbers for x that would make this true. Before we start, follow me on this thought experiment. I'm going to pick a random number here for x. Let's pick 10. And let's work out both sides. And what we'll notice is that we get a true statement. 68 is less than or equal to 98. Now what that tells us is that 10 is a solution to this problem. But it's not the only one. Watch this. What if I randomly picked 11 for x and worked out both sides? There's another true statement. So what we've just shown is that 10 is a solution and so is 11. But those aren't the only solutions. How are we going to find them all? Here's a trick. Take the problem and change the inequality into an equals. Then just solve the equation like you normally would solve any other equation. As soon as you're done, take the answer to the equation and put it on a number line. Then what you can do is pick any number to the right of that number. I'll randomly pick 3. Take the original problem, plug in 3 for x. Let's do the math and see if we get a true statement. Doing the math gives us 19 is less than or equal to 35. That is true. And that tells us not only that 3 is an answer, but that anything to the right of -5 is going to be a solution to this inequality as well. Remember earlier we showed that 10 and 11 were solutions? Since that's true, then we know every number to the right of -5 will be a solution to this inequality. Next, pick any number to the left of -5. I'll just try -7. Take the original problem, plug in -7, do all the math, and you will get a false statement. -51 is not less than or equal to -55. And since that statement is false, we not only know that -7 is not a solution, but we know that any number to the left of -5 will not be a solution. We can rule all of them out. Well, so far we've proved that everything to the right of -5 is a solution. Everything to the left of -5 isn't a solution. The last thing to try, -5 itself. So take the original problem, plug in -5, and do the algebra. When we do that, we get a true statement. -37 is less than or equal to -37 by virtue of the fact that they're equal. And so if that statement is true, then that means that -5 is also a solution. And now I've shown that every number -5 or higher works on this inequality. We can express that using interval notation. Let's take a look at a very similar problem where we change a less than or equal to into the strict inequality of just less than. In both cases, you would change them to equal signs, solve, just like we did before, put that number as the divider on your number line, and start testing points. Now, if we were to plug in 3, just like before, we would get a true statement, which tells us once again that every number to the right of -5 is a solution. If we were to plug in any number to the left of -5, like say -7 like we did last time, we would get a false statement and find out that there are no solutions to the left of -5. But because one of these problems has an equals built into it and one of them is strict and doesn't, what happens at -5 is going to be different. For the first problem, you'll remember from before when we plugged in -5, we got this statement. -37 less than or equal to -37 is true. And so we included -5 as part of our solution. By contrast, in the second problem, if we were to plug in -5, we would get negative 37 is less than negative 37. But a number can't be less than itself, so that's false. And if that's false, that tells us that negative 5 is not a solution. Graphically, we represent that with an open circle at negative 5. And finally, we could express our answers using interval notation. Here, a bracket around the negative 5 to indicate that negative 5 is a solution, and here a parenthesis at the negative 5 to indicate that it is not. Here's the same inequality we've already solved twice, but I'd like to show you a shortcut. Instead of turning this into an equation, we can just solve it directly by adding 2 to both sides and then subtracting 9x from both sides. In other words, treating this just like you would an equation. But here's where the shortcut varies a little bit. Here we'd have to divide both sides by negative 2. There is a rule in this shortcut that whenever you divide both sides by a negative number, you must reverse the direction of the inequality. Notice here I've changed less than or equal to greater than or equal to. This isn't true always at the division step, only when you're dividing by a negative number. But what this shows us is that x can be any number greater than or equal to negative 5. And on a number line, that's just negative 5 or higher, written this way using interval notation. Cool shortcut.